So here's a look at the Atwood's machine problem. And what we have is we have two blocks, a 2 kg block and a 3 kg block connected by a light string that passes over a pulley. Everything is frictionless. So we have a few things that we're going to do in this problem. One is we're going to find the acceleration of the blocks. Then, in addition to that, we're going to also figure out the time it takes for the 3 kg block to strike the ground. And once we've done this, what we'll also do is we'll figure out how high the 2 kg block rises after the 3 kg block has landed. So there are a few more additions to this problem. Now our line of attack is going to be very simple. We're going to first begin by drawing the free body diagrams for the two blocks, figuring out the acceleration. Once we get the accelerations, then we can go on and use 1D motion to figure out parts 2 and 3. There are a few things that one needs to keep in mind, and as we move along the problem, we'll make sure that, I'll try to remind you about those things. But what I would like you to do is, at each step, I'd like you to stop before you look at my work. Make sure that you try out the things and then verify the answer. Then you can always come back to the video and test what is going on. Alright, so let's begin by drawing the free body diagram for the 3 kg block. So if I look at the 3 kg block, the forces that are acting on it are going to be the force due to gravity, which is 3 times 9.8. Then you have the tension that pulls it up. Okay, and a result of these two things is that the 3 kg block will accelerate down at this rate. 3 times. It'll have a resultant force of 3 times A, which is ma from Newton's F equals ma. Let's repeat this diagram for the 2 kg block. And for the 2 kg block, you have its own weight, 2 times 9.8 pulling it down, the tension T pulling it up, and this guy is going to go upward. So I'm going to put 2 times A, which gives me F equals ma. Now that we have the free body diagram, let's write down the equations for each of the blocks. And we can always figure out, by looking at the picture for the 3 kg block. What we realize is that the weight is clearly greater than the tension, so we can do winner minus loser. So 3 times 9.8 minus T is equal to the resultant. And similarly for the 2 kg block, the tension is what wins, and so the tension minus 2 times 9.8 is equal to 2 times A. Alright, so we're done with an important part in the problem. We can now solve these two equations for the acceleration. And if you notice, there's a negative T on one equation and a positive T on the other. And when you have equations set up that way, in order to eliminate tension, all you need to do is add up the two equations. So I'm going to add these up. So I get 3 times 9.8 minus 2 times 9.8 equals 5 times A. So I get 9.8 equals 5 times A, and this gives me my acceleration as 9.8 divided by 5, which happens to be 1.96 meters per second square. Alright, so this takes care of part 1 of the problem, that A is equal to 1.96 meters per second square. Alright, now let's try to figure out the distance, or rather the time taken by the 3 kg block to land. So this is part B of the problem. Now while the 3 kg block is attached to the 2 kg block, what we know is that both the blocks have an acceleration of 1.96 meters per second square pointing downward. So let us make a chart, as we've done in the past. We have delta x, vi, vf, a, and delta t. We have 1.96, vi is 0, and the amount it moves is 1.5 meters. And we're going to use the equation delta x equals vi delta t plus 1/2 a delta t square, which happens to be 1.5 equals 0 times time plus 1/2 times 1.96 times time square. Let me 'So this gives us the time for the problem. And now with this time we can also figure out the velocity with which it lands, and this is simply equal to vi plus a times delta t, which happens to be 0 plus a, which is 1.96 multiplied by square root of 1.53, which happens to be 2.42 meters per second. Now, the 2 kg block is traveling at a speed of 2.42 meters per second right when the 3 kg block lands. So, in order to find how high it travels, we can set up another table with these values. Now we're looking for delta x here. We know Vi is 2.42, Vf will be 0, and now it's at the mercy of gravity, so it's going to be minus 9.8 meters per second square for the acceleration. And by using Vf square equals Vi square plus 2a delta x, we can figure out 0 square equals 2.42 square minus 19.6 times delta x, and this gives me delta x equals 5.9 divided by 19.6, which happens to be 0.301 meters. So this is our answer for this part. Alright, that's it for this problem.